There is another part with respect to moving or stealing resources from a local object during execution of the program. Observe that here we're also using assignment. So let's see if we can trace assignment when we execute this code. So we're using these trace statements. And I'd like to locate our assignment operator. It's called operator equals right here. So let's see if we can detect the execution of this assignment during our test cases. Alright, so here again I just call the same tracing statement and using it inside the assignment. So let's build this version of the program and run it. And you see that as we continue to run this program, of course assignments are used multiple times in our test cases. But once again, just before we return this version of the string from our test case, right here, right on this line, of course we invoke the assignment, and this is implementation of the assignment. And once again we run into the situation where we may be manufacturing a deep copy. So fortunately, just like move constructor that complements the copy constructor. So copy constructor typically is needed when we manufacture a deep copy with like copying every dynamic resource during the deep copy. And the move constructor is simply just taking resources away from another object and retaining it in the object that's being manufactured. So here, if we scroll down to the place where we declare our assignment operator, we can also complement this assignment with the move assignment. Okay, so this is basically deep copy assignment, and this here is a shallow assignment. So let's add this shallow assignment and see if we can revert to this version of the assignment whenever possible. And the nice thing about it is that compiler will decide when to use which one. Right, so this is to avoid unnecessary deep copy in a situation like this. If we have an object and we use its local version and we want to construct it, we want to avoid deep copy, and likewise we want to avoid deep copy assignment. So let's move this again. Let's take this signature of the assignment and try this as another version of the assignment. Okay, so what we need to do is, of course, we need to prefix our operator function with the proper name, and I'll say shallow assignment right here. Shallow assignment is actually called, technically properly called, a move assignment. Move. Okay, so this is like move semantics. Basically, move assignment or shallow assignment, and this is deep copy assignment. So let's just copy and paste the functionality that we're using in our code. Okay, so and let's just now redefine the workings of this assignment. So let's call this deep copy assignment, and this will be a shallow copy assignment, so we can distinguish between the two temporarily while we're testing those two versions of assignments. So what we would like to, of course, if this object, and let's just bring this back to dual screen view, and so if this selected string already holding some kind of dynamic resources, then of course we need to deallocate them. That's a given. So this is why we say, okay, if this object for which this is the left hand side of the assignment, it's holding some sort of dynamic memory, we will delete it. Okay, and there, beyond this point, all we have to do is basically transfer the ownership of resources to the left hand side of the assignment. Okay, so how do we do this? Well, very similar to what we did with the move constructor. So I think I'll just use this here, and I'll just use this statement. First of all, we can just simply assign the string view. We can take rpstr, okay, dynamically allocated string, and set it equal another pstr. So pstr is pointer to dynamically allocated block of characters, and then finally set another string pstr equal null pointer, which will prevent this, so it will no longer be responsible for holding this other string as a dynamic resource. So now the rest of this code can go away. And so this is an example of the move assignment, which is a shallow version of the assignment, which we would prefer to use when we're transferring string all the way from the local object already configured, being returned. The return is a copy, but we avoid copying because we have the move constructor, and now we also added this move assignment to the equation as well. All right, so let's give it a try. Let's do some testing, just a little bit. Again, I'm expecting that we will be printing these traces, and let's see if we can see this shallow assignment trace when we run this code. Right, so build this and then run it, and so you see that this shallow assignment becomes quite popular. We're actually optimizing many places where compiler recognizes the shallow assignment is actually a good version to use in the assignment. Okay, so there are plenty of situations where shallow assignment is actually being called. And let's see if we can also trace through the deep copy assignment as well. Yeah, so we already have this trace. So this is the version of the assignment which allows us to essentially optimize a move assignment, which allows us to optimize the code to avoid deep copying whenever possible. So once again, I'll just comment out this tracing statement, not to obscure our testing results, but this is an important part of string design, because this needs to be considered anytime you are designing an object which dynamically allocates memory. So we're talking about a situation such as, for example, objects that dynamically allocate resources. dynamically allocate memory, or maybe open a file, and an open file is a resource that you don't want to duplicate it anyway. In a deep copy version, you want to simply retain ownership, passing it from one object to another object. So with respect to this original version of the assignment operator, basically deep copy assignment, let's also add this code or comment at the top of it. So I think in a situation such as, for example, we already have this selected string, and now I will just create string, which will be called selected string copy. Okay, something like this, selected string copy. And so I will just take the selected string copy and say equals selected string. Okay, so obviously both of these objects have to be retained for the duration of this program, right? So the program hasn't finished yet, so obviously this is where we don't want to use the move assignment. We definitely expect compiler to choose a deep copy assignment for us. So let's see if we can observe this trace being printed at the end, and let's print selected string copy, the result of this assignment right here. So I guess we'll bring back both for the duration of this test, and just quickly run it and see what this looks like. Alright, so here we have it. So obviously, whenever possible, shallow assignment is invoked, but in this situation, because we have to retain both selected string and selected string copy, because they're really not any kind of temporary objects at this stage. They both can be used later on by our program. So you can see that it's a deep copy assignment that's being invoked by the compiler, while for all the cases that we already discussed, still the shallow assignment is chosen by the compiler.